Well, hello YouTube. In this tutorial we're gonna use C programming language to get area and circumference, probably I said that correctly, of circle. So here's the thing, if you use just 3.14 in your calculations, that result for area and circumference will be different than online calculators, because precision is different. So to be close to online calculators and Google calculator, we're gonna use 3.14159. Okay, we definitely need to do that, because if we don't do that, we can just be, maybe error can be significant. Right, so let's establish those floats. Pi, you can have it also as a constant if you like that, so it's totally up to you. 3 point blah blah blah, and we are calculating area and and input stuff is radius. Radius is half of the diameter. Okay, now print f. We need to grab radius from end user, circle radius, a little bit of new line. We are playing around with %f, which is placeholder for floats, and getting stuff inside radius. So that's the end user input. And area, well, what is a format here? Like p is, we do have that, times radius times radius. You can have this enclosed into brackets, but it's totally up to you, into parentheses, into these brackets. Okay, but as I said, it's up to you. Okay, so let's printf that, like where is that thing? Area, a little bit of new line, and of course this is placeholder f because we are working with floats. And where is my mouse? Area. Okay, and circumference will be, what is the formula? Well, times 2 pi times radius. Very simple stuff. Print f, we will say circumference. Probably I typed that correctly. Oh, again we are working with f's. A little bit of new line and connection with circumference, right? You can do this using like dedicated tables and functions and I don't know, but this is very simple stuff intended to be used by beginners. So let's see what is happening. Right, so 50 will be test input, because we're gonna use test input 50 also in online calculators to confirm what's happening. It's not important what kind of unit here is, like kilometers, millimeters, I don't know, who cares. And area is 7853, so let's check that. 50, and there you go, 785398. Close enough if you ask me. 758, absolutely same stuff after dot. So this was for area, and yeah, 50 for circumference, I mean for radius. End result is 314, 158, 159. Well, bearable guys, bearable. So I was talking to you about this precision. If you remove 159 and you run this stuff and input 50, now the difference will be obvious, where I was. So area, see, 7850, and here 3 is missing, 4 almost, and 314, and see, well, that's a relatively great difference if you ask me. I mean, it depends what kind of calculation you are doing. If it must be precise, you need to pay attention about that. But for school stuff, maybe you don't need that precision. But it is cool to use this value, okay, this value for some, let's say, real stuff. Okay, variables. Now, what about that constant? Well, here you can say define, and pi will be this number. Okay, and then we will propagate that thing down. So we don't need this thing then. Okay, and what we need is right here, pi. Okay, I'm a little bit lazy, so I'm copy pasting and not typing. I don't know, I'm just like that, sorry about that. Sometimes I confuse myself and also other people, but there you go. Okay, so let's test that one more time. 50, and again, but we have that result, but through this constant. So it's kind of nice, once when you set it, you don't think about it. And you can use it all over the place down there. Once when you change it, that change will propagate. Constants are very cool stuff, especially when you're working with, well, obviously hard-coded data, like voltages in lines, like speed of motors, like, I don't know, like color of diodes on electronic. Harder stuff. Right. Well, yeah, this thing works. So guys, thank you for watching. Share this channel with other people. Thank you for subscription, and see you in a couple of minutes. Ciao, ciao.